Good morning, friends. Welcome back. Today we will be discussing one more important problem in operating systems, that is the reader writers problem. As in my previous lectures, you have seen the producer consumer problem and the solution to the producer consumer problem. This is similar type of second problem that is called as reader writers famous synchronization problem. On moving on to the problem statement of reader writers problem, as you have already seen how the producer consumer problem works, what is the solution to that particular producer consumer problem, and how to overcome the solution by using semaphores. Now, my dear friends, moving on to the problem statement for reader writers problem. The reader writers problem is a classical problem of process synchronization. All the problems which I am discussing are related to the core topic of process synchronization. It relates a data set such that a file is shared between more than two processes. So, the reader writer's problem is mainly used to manage the synchronization among various reading and writing processes. So, such that there are no problems with the data sets and no inconsistency is generated. For example, before going on to the problem statement, let us understand this through a simple example. With an example, I will first make you to understand what is the reader writers problem. Then I will go into the different cases that are present in the reader writers problem. Suppose let us see, if there are two readers and there is a single file that is stored in your local disk in your computer. Now, both the readers want to access the file at the same point of time. There will be no problem, because from my particular laptop I can open the file and read the content that is present in that file. Similarly, the another reader can open the file from his laptop and he can read the content in the file, or else I can open the same file in one particular device and multiple readers can sit and read what is there in the file. Now, there are some situations where, like, two writers or one reader, or one writer and one reader want to access the file. This is the point where problem occurs. If one writer is writing and no reader is allowed to read. Similarly, if one writer is updating a file, other writers should not be allowed to update the file. Similarly, when one reader is reading the file, a writer is not allowed to write anything and update the information in the file. So, these are the constraints that we have to follow in the reader writers problem. Now, as you have can see, mainly there are four cases that are present in the reader writers problem. Now let us take process 1, process 2. As I have told you, moving on to the first case, when process 1 is writing something into the file, similarly when process 2 is writing into the file, no reader is allowed to read the content from the file. So you can see the operation given here is not allowed, which means that no reader or no writer is allowed to write into the file. So it is given as, it is given as not allowed, which means that no reader or no writer is allowed to read the content from the file. Next, coming to case 2, process 1 is writing into the file, whereas process 2 is reading from the file, which means that one writer is writing, another reader is reading. Then also it is not allowed. Now, when moving to the third case, one process is reading, another process is writing. Then also the updation is not allowed. Coming to the case 4, both the process are doing the same task, reading. So it is allowed. So multiple process can sit and read the same file, but multiple process cannot write on the same file. Multiple process, when one process is writing and one process is reading, another process doesn't have the chance to alter this. When one process is reading, another process is writing. Similarly, the another alternate external process do not have the chance to edit the file. Now, moving on to this, for establishing a solution to this particular problem, first we will understand what variables are declared within the code that we are going to discuss in further. Semaphore is a variable that is declared mutex. As you all know, as I have discussed in my previous video, mutex is used as a gate signaling for the reader as well as writer. Now, int read count. Read count is another variable that is declared. So this read count tells the number of process performing reading in the critical section. So this read count like will be a diary or a note for the writer process to understand how many reader process are performing reading in the critical section. Now, as you all know, these two are the basic functions that are performed by a semaphore. Wait operation and perform a signal operation. Wait operation decrements the value of semaphore, signal operation increments the value of the semaphore. Now, now we will see certain constraints for writer process. Writer requests the entry to the critical section. Yes, if allowed, which means that if writer is allowed into the critical section, which means that critical section is empty, no one is accessing it at present, and there is no reader present in the critical section. If allowed, wait gives a true value, which means that it decrements the semaphore value. It enters and perform the right operation. As writer is allowed, writer process is allowed, it performs the right operation. If not allowed, it keeps on waiting. Once this particular writer process, after entering into the critical section, completes all of its execution process, completes the work that it wanted to complete by writing, it will be immediately sent out of the critical section. That is nothing but it exits the critical section. Now, this is the code, this is for writer process. Now, let us see what is the code for writing process. As you have seen, this is do, we are opening the do condition. This all the process will be performed within the do while loop only. So this is do. Now, as I have told you, the first point, the writer requests for the entry into the critical section. See, wait of write, which means that write is a variable. Wait operation will perform is decrements the value of the semaphore. First it will request whether I can enter into the critical section or not. So if suppose it this wait returns true value, this wait returns true value, which means that yes, permission is granted for the writer to enter into the critical section and perform writing operation. So it will enter, it performs the write operation and signal of write while true. It leaves the critical section. Signal of write, which means that this which when the writer enters into the critical section, this particular write value will be going to -1, which means that if a reader in turn comes in between and checks or tries to enter into the critical section, by seeing this write variable, he will understand that someone is already accessing or some process is already present in the critical section. So the external process p which had come should wait until this critical section becomes free. Okay, suppose this is the critical section, this is the critical section, this is already being accessed by a process p. An external process p comes and tries to enter into the critical section. Before entering, this particular write variable will act like a barrier, which means that this write will be showing a value of -1 to the incoming process. So when the incoming process sees the value of -1, it will understand that there is some other process which is already in touch or accessing the critical section. So I have to wait until this particular process p comes out of the critical section, then only I will get a chance to enter into the section. Okay, this is the code for writer process. Now similarly the code for reader process, do while loop again. Do, you can see here do while. Now wait of mutex, which means that here in this wait of write, the writer had asked for the permission to enter into the critical section. Here the reader will ask the permission to enter the critical section. The number of readers has now increased by 1. As I have told you, here we will declare a variable called read count to maintain the count of number of readers in the critical section. So here we will increment the value of read count plus plus. Now if read count is equal to 1, wait of write, which means that if read count value is equal to 1, which means that there is already a reader that he is present in the critical section. Meanwhile time, if a writer comes to write some data in the critical section, it will show a stop, it will tell to stop, wait. there is one reader already present in the critical section. So the writer, the outcoming writer has to wait until this becomes signal of write. So signal of mutex. Other readers can enter while this current reader is inside. Signal of mutex is for particularly for readers. Now, wait of mutex. Current reader performs reading here and a reader wants to leave. Suppose, as I have told you, signal of mutex will allow multiple readers to enter. Multiple readers, not writer. Multiple readers can enter. It will allow multiple readers to enter into the critical section. Read count minus minus decremented because a reader has left the critical section. Now this read count value is again checked. If read count is equal to 0, signal of write. Here it has become wait of write. Now which means that no writer can enter. Signal of write, which means that all the readers have completed their reading and left the critical section. Now the critical section is empty. So the writers can enter, and the signal of mutex is yes, it is giving a green like the readers has left, now you can enter. Now we have seen what is the, now on understanding both of these codes, we have come to see in the problem that when one reader is reading, another writer cannot enter into the critical section and write the data. Similarly, when one writer is writing in the critical section, no other reader can enter and read into the critical read the data. Similarly, when one writer is writing the data into the critical section, another writer cannot enter, write anything, or update the critical section. So these are some of the problems that we have seen in the particular reader writing problem. Now we will see what is the solution to the particular problem. In order to solve the problem, we maintain three variables, namely mutex, semaphore, and read count. Okay. Mutex makes the process to release and acquire a lock when the read count is being updated. The lock is acquired when the read count is updated and decremented back after it has done performing the operation. The writer waits for the semaphore until it is turned to write and increments for the other process. The idea remains to use the semaphores. When a reader enters the critical section up till it exits the critical section, a semaphore is used to prevent writers from accessing. So, as I have discussed the solution for you in the form of code, this particular explanation is given. In place of this code, this explanation is given how this solution is implemented using semaphores. So, with this lecture, all the famous process synchronization problems have been covered. I think there is one more problem, that is the DP problem called as dining philosophers problem, that will also be covered in the upcoming lectures. With that, we will wind up the process synchronization topic and we will move on to the important next topic of operating systems, that is the disk scheduling problems. Disk scheduling in operating systems. Thank you.